We're going to find the value of the arc length of the given function. In particular, this one we have y equals x squared over 2 minus the natural log of x over 4 on the interval from 1 to 3. So you may recall that the arc length is given by the relationship of the arc length, right? So that we have the square root of 1 plus the derivative squared of the function f. In this case, f is this y of x dx in this interval. And we're doing that with respect to x because we're looking at the partitions along the x-axis and we have our function in terms of x. Okay, all right, so let's go ahead and I like to calculate kind of like the stuff underneath the square root first. I find that plugging it in with the integral and writing all that kind of makes things convoluted. So just for the sake of simplicity, I'm going to calculate the derivative, then square it, and then add 1 to it to see if I can simplify it before I plug it back in. Okay, so we have y prime of x is equal to, using the power rule, bringing down the 2. The 2's are going to divide out. And I reduce the exponent on the x squared to 1, or by 1, I should say. Okay, and then the derivative, the constant term 1/4, this comes out in front. And then the derivative of the natural log is 1 over x. Simplifying all this, we get x minus 1 over 4x is our result there. Okay. So now that we have the y prime, we're going to square this function. Okay. So now let's look at what does y prime of x squared look like. Well, that would be x minus 1 over 4x squared. Okay. So let's FOIL that out. We have x squared multiplying x times x, if you can imagine 2 of them, minus, there's going to be an x times 1 over 4x. So that's going to give us a 1/4. And then you're going to have another x times a minus 1 over 4x. So it's going to be a minus 1/4 again. And then you're going to have a minus 1/4 x times a minus 1/4 x. So it's going to give us plus 1 over 16x squared. Okay, simplifying that a little bit more. We have x squared, a half, minus and a minus make that a half, minus 1/2, plus 1 over 16x squared. Okay, and then we still have, so that's this term all squared now, and so now we have to worry about the plus 1. Okay, so now we have 1 plus y prime of x squared. We know what y prime of x squared is. That's this whole wonderful thing over here. So we have 1 plus x squared minus 1/2 plus 1 over 16x squared. Okay, so the 1 minus the 1/2 gives us 1/2 plus x squared plus 1 over 16x squared. Okay, and now it looks like maybe the last thing to do would be to get a common denominator. It looks like 16x squared will do it for all of the terms. So if I look at what do I need to multiply each of these by, I would have, well, 1/2 it needs to be multiplied by 8x squared over 8x squared plus, well, 16 x squared doesn't have either of those. It's going to need a 16x squared and a 16x squared to match the denominators, and then of course the plus 1 over 16x squared. It doesn't need anything, so it's got that. Okay, combining like terms, it looks like we have a 16x to the fourth. So I'm going to write them in standard form, so highest exponent is 4, so 16x to the fourth looks like plus 8x squared, looks like plus 1, all divided by 16x squared. Okay, now what I notice here is this is an x to the fourth, and that's 4, or 16 is a perfect square, right? So that's 4. And then we have a double the normal amount here. So this looks actually like a perfect square trinomial of the form of 4x squared plus 1. In fact, that's exactly what this factors to. So this is 4x squared plus 1 squared divided by 16x squared. And so this is a really nice form because the square, we have two perfect squares here. And so now that we have, going back up to our integral here, we want to take the square root of this. And since these are both perfect squares, the square root and the square will cancel each other out. And so the length then is equal to the integral from going back up to our original problem was 1 to 3 for limits of integration. And so we have the square root of 4x squared plus 1 quantity squared over 16x squared dx, canceling out the square roots, and assuming on the interval from 1 to 3, these are all positive, so we don't need to worry about the absolute value. Okay, so the integral from 1 to 3, we're going to get 4x squared plus 1 divided by 4x squared dx. But I said 4x squared, sorry, that should be 4x. Let's go canceling the square. Okay, and now this kind of looks like it might be a difficult integral to do, but realize that we have a common denominator. And in this term, in this case, it actually is easier to break it up and then use the power rule to simplify this. So we have the integral from 1 to 3. We're going to have 4x squared over 4x plus, using that as the common denominator, plus 1 over 4x dx. Okay. These cancel, right? So the 4 and the 4 reduce to 1, and then the x and the x squared reduce to just 1x. So I'll write it out just so that we're clear. This is going to be x plus 1/4, 1 over x dx. Okay, so now I can integrate each of these terms since the integral is a linear operator. So the integral of x is x squared divided by 2, evaluated from 1 to 3. And then I have, adding on to that, the 1/4 term gets factored out. This is the integral of 1 over x, which you saw earlier was the natural log of x, evaluated from 1 to 3. Okay. Now you'll notice that the natural log of 1 is 0, so we technically don't need to worry about the lower limit of integration here. If we plug everything in, we have 1/2 3 squared minus 1 squared plus 1/4 natural log of 3 minus natural log of 1. Again, this is 0. This is 9 minus 1, so this is 8. Half of 8 is 4. Okay. And then we have 4 plus 1/4 natural log of 3. Okay, so we could simplify it a little bit more. We could factor out a common term, or we could use this up here as an exponent. But that is good for now. Right, I hope that was helpful, and I'll see you in the next video.